Okay, so welcome to our practice writing ionic compounds, and we're just going to go through your practice. So we have lithium, lithium's right here, charge +1. Oxygen's right here, -2. I know the positive one's going to come first. This is how many. The negative one's going to come next, and that's how many. So calcium, it's right here, it's +2. Phosphorus right here, -3. The positive one's going to come first. That's how many. The phosphorus is going to come second because it's negative, and that's how many. Aluminum is +3. And oxygen is -2. So the positive one's going to come first. That's how many. Oxygen, and then that's how many. Now this is an interesting case, so let me just go through this with you slower. So we have beryllium, beryllium is +2, and we have sulfur, which is -2. When you have a charge that is exactly the same, that is going to mean that they're going to combine in a 1-to-1 ratio. So when you write the formula, you're going to put the positive one first, and then the negative one, and you're going to leave off the 2's. Because this formula tells you how many reacts with how many, so it needs to be the lowest common factor. Sodium, +1. Fluorine, -1. So NaF, they're both 1's. So up until this point, I've put the positive one first for you, just to make your life easy. From here on, I'm going to mix it up. So silicon is + or -4. So you may be thinking, well, how am I supposed to know if it's a plus or minus? And it's going to be determined by what it's reacting with. So calcium here is +2. So if calcium is +2, our silicon is going to be -4. Because the whole thing with ionic bonding, right, is that opposites attract. Positive one first, so this time calcium's first, even though it's listed second. 4 is how many? But do you see how it's a 2 and a 4? So they're going to reduce. So this is going to be 2, and then silicon will be second, and that'll be 1. Again, let's talk about why I did that. So this is a 4 and a 2. Just like the 2 and the 2, they're going to reduce. So 4 and 2 would reduce into 2 and 1. Okay. So next we have calcium, which is +2, oxygen -2. So calcium will be first, and then oxygen, and no subscripts because they're the same. Cesium is +1. Sulfur is -2. Cesium will be first, and we'll have 2 of them. Sulfur will be next, and we'll have 1 of them. Chlorine is -1. Magnesium is +2. Remember, put your positive one first, and I only have 1. And then for chlorine, I have 2. Fluorine is -1. Calcium is +2. Calcium first, and then fluorine. Francium is +1. Bromine is -1. Francium is going to come first because it's positive, and then bromine, and they're both 1's. Gallium is +3. Iodine is -1. Ga1, I3. So now we're reversing it again. So the better you know your symbols, the easier this will be for you. Otherwise, you'll have to look it up. So germanium and sulfur. So remember, to figure out the charge, we're going to look at the other one because this one's a little tricky. So right now, it looks like germanium's charge is +2 and sulfur's charge is -1. You may know by now that that's not true. Sulfur's charge is -2. Every time we see sulfur, charge is -2. So that means this is actually -2 and this is -4. Hydrogen and iodide. And they both have +1 and -1. Indium, nitrogen, and they have the same charge. I know they have the same charge, I don't know what that charge is, so just look one of them up, and it's 3. Lithium, and oxygen, and oxygen is -2, lithium is +1. Magnesium and iodide. Magnesium is +2, iodine is -1. Just to make sure that you're getting how I'm doing this, I'm going to blow this guy up and show you. So Al is aluminum, and F is fluorine. To get the charge, I'm uncrossing them. Aluminum's charge was +3, and fluorine's charge was -1.